guys, it's Miss Nelson.
Miss Hall.
And today we're going to be covering proportional and non-proportional relationships. So we have covered these already in great detail, but now we're actually going to break it down and kind of give you a list of how to identify proportional and non-proportional relationships so that you can identify them when you see a problem about it. So we're going to start with the proportional relationships first. So in a table, you will see the points 0, 0, or have the possibility of seeing the point 0, 0. It may not show up, but that doesn't mean that it's not there. In a graph, you know it's proportional when your line crosses through 0, 0. We have spent a lot of time talking about this. In an equation, our equations are either going to be in y equals kx form, where k is your rate of change, or it could be y equals mx, where remember m is your slope, which is the same exact thing as rate of change. And in a scenario, okay, some examples that you could be asked to find is hourly rate, miles per hour, anything that says each, or per, or every. Okay, anything like that, as long as there is no additional piece added to it, then you know that it will be a proportional relationship.
Okay, so for non-proportional, you're on your table. It's your y-intercept will be 0, n, where n is does not equal 0. It can be any number but not 0. On a graph, the line does not go through 0, 0. And then on your equation, it's going to be y equals mx plus b. Remember, we talked about b is your y-intercept, but b cannot equal 0. It can be any other number, but not 0. And on scenarios, look for flat rate, like a setup charge, where it says plus, like a starting, like we did the water level one, so it's a starting point. And remember, it does not have to be positive. It can be a negative number, but any number that is not 0, obviously.
Okay, so let's look at our first example. So we have a table that we are to determine if it represents a proportional relationship or not, and explain. So it's asking us for y over x, which is our slope, change of y, change of x. So I'm going to start by identifying 2 points. Remember, you can choose any 2 points. So from 5 to 8, my change is a 3. From 10 to 16, my change is a 6. So when I set up 6 over 3, that gives me a slope of a 2. So my equation would be y equals 2 times x. So if you look at the table, if you see that you do not have a 0, 0 in it, I have one of 2 things I can do. I can back it up by subtracting 2 on the left and 1 on the right each time, or that substitution method that we showed you. So if I start with my equation, y equals 2x, and if I choose, it says when x is 0 right here, so 2 times 0, what is my y output? Your y is also going to be 0. So we know that it is proportional, and we can explain because the table could show 0, 0. It doesn't, but just because it doesn't show it doesn't mean that it's not proportional. We can back it up or substitute and prove that it does.
Okay, y'all do the example, try the example on the right, and I'm going to example 2. So we're doing the same thing, trying to decide if it's proportional or non-proportional, but this side is the table they actually gave us an equation. So we have y equals 3x plus 1. We know y equals mx plus b. Our m, what the number that is in our m position, is our slope. So we know change in y over change in x, which is our slope, is 3. Our y-intercept is the number where it's in the b position, and so that is 1. So because there is a y-intercept that is not 0, we know it is not proportional because it does not go through. If you graph this, it does not go through 0, 0. Okay, try the one on your right.
Okay, our third example says, again, now we have a graph and we are determining if it's proportional or not and explaining. So when we have graphs, we taught you guys to put your point where it crosses the y-intercept. So that would be right here. If this is my y and this is my x, that means that it physically actually meets at the origin. So if a line goes through the origin 0, 0, you know it is proportional. So let's go back. My y-intercept is 0, because that's physically where it crosses the y-axis is at 0. So to find my slope, I'm going to find another point that crosses exactly at the corner of my back grid in the background, which is right here. So I'm going to do rise over run. And my rise, I go up 1, and I run 3. So my slope is a 1/3. So my explanation as to why this graph is proportional, I'm going to say the line goes through 0, 0. So now you try the graph on the right.
Okay, so our last example is a word problem. That's what we did the Friday before our Thanksgiving break. So we're going to read our problem now and get our information out of it. At HPMS, there are 26 students per teacher in advisory. So the only number we have is 26, and since we have the per there, use your strategies, you know that is the number that is attached to your variable. So our equation is going to be y equals 26x. So we know our slope, which is change in y over change in x, is 26. That means for every teacher, there's going to be 26 more students. Our y-intercept is 0, 0, because if there's 0 teachers, there's 0 students. It is proportional because it goes through 0, 0. Our explanation is 0 teachers would be 0 students, which means the line would go zero, 0. Okay, try those, the other 4 examples. Come in with any questions you might have tomorrow.
Bye.